Dear students, in the last video we obtained the equation of electrostatic potential at any point due to the point charge. So the formula was V equal to K Q by R. See, this is the source charge. If the source charge is positive, potential will be positive. If the source charge is negative, the potential will also negative. Potential may positive, may negative. Potential is a scalar quantity. The SI unit of potential is volt, V-O-L-T, volt. Right? So here the potential is proportional to the, inversely proportional to the R. Right? So these many are the important points regarding the electrostatic potential due to the point charge. So keep in mind. So today we are going to see the next question. See the question: obtain the formula for electric potential due to the dipole. So due to the dipole, we are going to find out the electrostatic potential. Okay, see. For that purpose, we will draw the diagram of electric dipole. See. Okay, look at the book. This is a, suppose it is a positive charge, it is a negative charge, and they are separated by some distance, that is 2e. This is the center of the dipole. So this is the dipole, kept vertical, and we are interested to find the potential at point P. Suppose anywhere, suppose this is the point P, and we are interested to calculate the potential at point P. So the P point is at a distance R1 distance from the plus Q charge, and this P point is at a distance R2 from the minus Q charge. So distance is R2, and from the O the distance is R. Right? We can draw it as a vector, R vector from this O to P, it is known as the R vector. So, as we know that, suppose the potential at point P, to calculate the potential at point P, there is a potential at point P due to the plus Q charge and due to the minus Q charge. So, we write over here potential at point P, V1 plus V2. What is V1? Potential at point P due to the plus Q charge. What is V2? Potential at point P due to the minus Q charge. So we know the formula is V potential due to the plus Q charge. So K we will write that is plus Q, distance is R1 plus V2 potential at point P due to this minus Q charge. So we write K minus of Q divided by this R. Finally, what is potential at point P? Will be equal to K Q by R1. Here it becomes minus K Q by R. Right? So this is our formula, equation number A. Now we are going to calculate the value of R1 and R2, and then we put in this equation and we will get the final equation, that is potential at point P for R1. Right? To calculate the value of R1 for R1, we will consider the diagram. See, this is the distance A, 0 to plus Q charge. We are drawing the diagram over here. Suppose this is the O point. Here it is a plus Q charge. Right? This distance is A vector. In the vector form we will consider. Suppose this is the P point. The distance that R1 vector, and it is another R vector. Students, we just concentrate over here. Suppose this angle is theta. Here the angle is theta. This is the first vector we can consider, 0 O2 plus Q charge, A vector. On the head of the first vector, the tail of the second vector is kept. Right? So R1 is the another vector and tail of the R1 is kept on the A vector. And see, the tail of the first vector is connected with the head of the second vector. So R vector is connected by the tail of the first vector and head of the last vector. So using the triangle law method, A vector plus R1 vector equal to R vector. So resultant of this R vector equal to what we can write? R vector equal to, we can write A vector plus this R1 vector. We want to calculate the value of R1. So R1 equal to, we will write R1 vector equal to R vector minus A vector. Now simplifying this, suppose we are multiplying this equation with the same. So R1 vector into R1 vector equal to R vector minus A vector dot again R vector minus A vector. Look at the board properly. R1 vector dot R1 vector equal to what? R1 square. That is R1 R vector into R vector, that is again R square minus R vector into A vector, R vector into A vector minus of A vector dot R vector. Minus become plus. A vector dot A vector becomes A square. So rearranging the equation, R square equal to R square plus A square minus means 2 times R vector dot A vector. Right? So here we can apply the formula R vector equal to R square plus A square minus, right? We will write 2 into R A cos theta. Theta is the angle between R and A, right? Angle between R and A, that is theta. So taking square root on both sides, what will we get? R1 equal to under root C R square plus A square minus 2 AR cos theta. That we can write. Correct? Now, taking R1 common, so what we can write, that is R1 as it is equal to under root means we will write raised to half. Correct? We are taking R1 square common. So R1 square common, 1 plus R1 square outside, so it becomes 1 plus A square by R square minus of 2AR cos theta divided by R square. This R get cancelled. Only R will remains over here in this way. Correct? So R square raised to half. Take it outside. So R1 equal to R, right? Taking R outside from the root. So it becomes 1 plus A square by R square minus 2A cos theta divided by R raised to half. Correct? Rearranging the equation, suppose I want to calculate the value of 1 by R1. So take the R1 over there, so we can write 1 by R1 equal to 1 by R. Right? In this way we write 1 plus A square R square minus 2A cos theta by R raised to half. In this way. Now taking this upper side. So 1 by R1 remains as this, 1 by R remains as this, taking this bracket on the upper side. So we will write like this, 1 plus a square by r square minus of 2a cos theta by r raised to minus of r. Right? Are you getting it? So using the binomial expansion over here and neglecting the higher order terms, see what is the final equation? 1 by r1 equal to 1 by r. Here we can say that this distance, the p is at a large distance. P is at a large distance. So r is very greater than as compared to this small a. So neglecting this term, first of all, neglecting this term, we will write 1 minus of 2a cos theta by r raised to minus of r. Now using the binomial expansion and neglecting the higher order terms, we will write 1 by r1 equal to 1 by r, multiplying this 1 by r square over here, 1 plus 2a cos theta by r into this half, right? So 2 get cancelled. 1 by r1 equal to 1 by r. 1 plus, your equation will be a cos theta divided by r. This is the value of 1 by r1, and we will write it somewhere. So suppose we got the value 1 by r1 equal to 1 by r, 1 plus, that is a cos theta divided by r. Correct? So this is the value of 1 by r1. So we got 1 by r1. Now for the 1 by r2. So you just take the note. I am going to erase this, right? Take the note. Okay. For r2, we will draw the new diagram for r2. We will repeat the same procedure. See, this part we are going to draw O minus Q and P point. See, this is the O point minus Q charge, right? Minus Q charge, sorry, it is a O point, origin of the dipole, minus Q charge, and here it is the P point. From O to P it is a R vector, from minus Q to P it is a R2 vector, and from minus Q to O, that is again a vector. Now the angle, this angle, it is a 180. So 180 minus theta. This angle is 180 minus theta. So here we write 180 minus theta. Correct? See, same thing we are using over here. A vector, this is the first vector, second vector, and this is the resultant of these two vectors. First vector on the head of the first vector, the tail of the second vector is kept. So obviously it will be a R2 vector will be the resultant vector. Using the triangle law method, we will write R2 vector equal to first vector plus R1 A vector plus R vector. Right? We are going to calculate R. So the first step was multiply the equation with the same equation. So R2 vector multiplied by R2 vector equal to A vector plus R vector dot A vector plus R vector. So it becomes R2 square, right? It becomes A square plus it becomes r into a vector plus, right, a vector dot r vector plus r square, r into r square, r vector dot r vector. So here r2 vector equal to, rearranging, a square plus r square plus 2 times a vector dot r vector. Here r2 square equal to a square plus r square plus 2 times a r cos, angle between a and r, a vector and r vector, angle between them is 180 minus theta. 180 minus theta. As we know that cos 180 minus theta is again cos theta. So taking square root on both sides, r2 equal to under root a square plus r square plus 2ar cos theta. Right? Now r square taking outside. We can rearrange the equation. R square plus a square we can write r square plus a square can in addition. So we can write like this. So one r2 equal to r2 equal to, correct, taking r square common inside the bracket. Suppose this is square root raised to half. What we taken outside? R square taken outside. So 1 plus a square by r square, by r square plus 2a cos theta divided by r. R will cancel. Only one r will be there. Correct? So in this way. Take the r square outside the root. R2 equal to r, right? 1 plus a square by r square plus 2a cos theta by r raised to half. Correct? Now neglecting the a square by r square as we did. This p is at a very large distance. So the r distance is very large as compared to this a. That's why neglecting this stuff. Correct? So r2 equal to r in the bracket 1 plus 2a cos theta divided by r raised to half. We want to calculate 1 by r2. 1 by r. So rearranging the equation, 1 by r2 equal to 1 by r. Right? Like this we will do 1 plus 2a cos theta by r raised to half. We will take the term upper side. 1 by r2 equal to 1 by r remains as it is. Here 1 plus 2a cos theta by r raised to minus half. Now using the binomial expansion and neglecting the higher order terms. So 1 by r2, 1 by r2, 1 by r equal to, right, here we write like this. So 1 plus, it is minus half into 2a cos theta by r. So this minus 2 get cancel. Final equation, 1 by r2 equal to 1 by r, 1 minus a cos theta by r. This is the value of r. So we will write again the value of r2 over here. See, 1 by r2 equal to, right? We will write over here 1 by r2 equal to 1 by r, 1 minus a cos theta divided by r. This is the value of r. Right? Now we got the value of 1 by r1, we got the value of 1 by r2. Now we will put the 1 by r1 and 1 by r2 in this equation and we will get the final equation. So So you just take a note, right? Okay. So erasing all the boards. Okay. See, what was our equation? Vp equal to, that is K Q by R1 minus K Q by R2. That was our equation A. Right? We calculated the value of 1 by R1 and we calculated the value of 1 by R2. So Vp equal to KQ taken outside. 1 by R1 minus 1 by R2. Vp equal to potential at point P. K, Q remains as it is. The value of 1 by R1 is 1 by R in the bracket 1 plus A cos theta by R. This minus 1 by R2 equal to 1 by R in the bracket 1 minus A cos theta by R. Bracket complete. Correct? Vp equal to KQ remains as it is. Multiply this 1 by R in the bracket. So it becomes 1 by R. Here it becomes A cos theta by R square. Minus, this minus will multiply over 1 by R. Minus minus plus A cos theta by R square. Bracket complete. See, this term get cancelled. Correct? So Vp equal to KQ. A cos theta by R square, A cos theta by R square, it becomes 2 times. So 2A cos theta by R square. As we know that this 2A into Q is known as the P. So potential at point P equal to K P cos theta by R square. This is the potential due to the dipole, right? Vp equal to K P cos theta, where the P is dipole moment, 2A into Q. P the dipole moment, P equal to 2A into Q. So Kp cos theta by R square, right? The potential due to the dipole vary 1 by R square, inversely proportional to the R square. Correct? So this was your answer of the question. Obtain the formula for electrostatic potential due to the dipole. Correct? So in the next video we will see the next expression. Thank you.